Okay, so in this section, we are going to talk about some log rules. So this is logarithmetic, and we say log for short. So let's kind of go through all the rules all at once, and then we'll do some practice. Rule number one, if you have log of something multiplied by something inside that log, then we can actually split this into two logs, log base b of the first one, which is m, and then this multiply sign here is actually telling us we can split into two logs that are added together. And then the second one will also have a log base b, and then this time is an n. So just remember that if you have something that's multiplied, it ends up being a plus sign here, but then you got to make sure that's two logs added together. Okay, notice here how I have written this b here. So log with the space is slightly below log. So, what you want to do is kind of see that if I were to have some levels to with how I write these things, log and m would share the same level, and then b is slightly lower like a subscript. So you need to make sure how you write these very clearly, because once we get down to like rule 6 or 7, then there are so many levels that if you don't write them clearly, you will actually calculate them wrong. So please be careful of that. Okay, so this is how we kind of expand it, take something like this and then expand it to this, which actually basically tells us like we can actually go backwards. If you see two logs that have the same base, we can go backwards and then create just one log, which we'll practice in the next chapter. All right, let's look at rule number 2. When two things are divided by each other, then we can split it again with two logs, but this time we're going to take the top one, the divide means minus, and then the other log, like so. Okay. All right, rule number 3. Log, so you see here how the levels is very, very important, because you can see that this log and m is sharing the same level. This b is slightly lower. And then we have this exponent k that is on top of m. So when this happens, this exponent k, which is on this thing that's inside the log. Okay, so this is kind of the important part. This exponent actually can go to the front of the log as a coefficient. So this k can go to the front, share that same level as the log. The b is slightly lower, and then we have an m. So that just tells us that this exponent can go to the front as a coefficient. I'm sorry, exponent can go to the front as a coefficient. Rule number 4. Rule number 4, any log of 1 is 0. So you just kind of memorize that. Any log of 1 is 0. All right, rule number 5 and 6. Number 5 and 6 are very similar, and let's talk about rule 6 and then go back to rule 5, because you'll see why rule 5 is the way it is. Okay, so this is where you look at this and you say, if this log base every log has a base. If this base and this exponential base are exactly the same, then it's very nice, because that whole thing cancels. And then we have a k left over. So you're always looking to see if the log and the exponential can have the same base, because when they are the same base, they just cancel out. So this is kind of the nice part. So now that we know this rule, let's go back to rule number 5. So you can see that this log base and this exponential base are the same. So that's nice. That's going to cancel. But then you ask yourself, well, if I cancel that, then what's left over? Hopefully you don't say 0, because this b really is a exponential to some power, right? B is the same as b to the first. So then when this cancels, you just get a 1. Okay, so you have log base b of b, and that just gives you 1. All right, let's look at rule number 7. This is kind of the crazy one. That's why you kind of have to make sure your levels are kept very consistent. So you have b as the exponential to a exponent, that exponent being log, with a base b, and that k and log are the same base. So this is the same rule as before. Anytime you have an exponential and then the log having that same base, it just cancels. So this is just k. Okay, so we're always looking for that log and the exponential having the same base, because when that happens, things just cancel. All right, so this log rule has some extra rules. First, this base can only be greater than 1, so you can only have a positive number, but that positive number has to be greater than 1. M, N, and K can be any real numbers, but M and N have to be positive. And then, we'll see why later on in section 5 when we have to solve for log problems. All right, let's go ahead and evaluate the following. We're going to do all of these problems with no calculator. Okay, log base 2 of 8. So we have to figure out what that number is. Remember, the whole idea is we want this log with some base and this number to have the same base. So if you look at this log, just this log, what is this base? This is a base 2. What about this 8? What is the base on this? Well, that's just a base 8. Well, 2 and 8 are not the same, so we can't really do anything with this problem. However, we need to be a little bit clever on this and then say, you know what? Can I change 8 so that it has a base of 2? Can I change 8 so it has a base of 2? Well, we can. Let's think about 8. So we'll probably spend some time in class memorizing powers of powers of numbers, so then it's easier to solve them. Okay, so for now, let's just kind of work on this. 8 is 4 times 2. 4 is 2 times 2. So essentially, 8 is the same as there are 3 2's multiplied together, so it's 2 to the third. So then we can say this 8 is 2 to the third. All right, now we have log with a base 2 and an exponential with a base 2, so they cancel. Answer is 3. Okay, so again, we're looking for the log base and the exponential base to be the same number. All right, let's look over here. Log base 3 of square root 3. So I can see those 3's are repeating, so that's nice. I'm going to somehow make them be the same base that's right next to each other. But at this time, they're not right next to each other. There is that square root that's blocking the way. So how do I change the square root 3 so that it's 3 to a power? In another word, what is the power form or the exponent form of square root? Well, hopefully you kind of remember this from Algebra 2. Square root means second root. And then this 3 has no power, so that's the power of 1. So then this square root just means half power. Okay, so if you don't remember this, I feel like we had reviewed this at the beginning of the year, but if you don't remember this kind of, let's change this. So this is always like so. This power goes up here, and then this root goes as the denominator. So a quick example, so if you have third root of x squared, it becomes x to the 2/3. All right, let's come back to this problem. So log base 3 of 3 to the 1/2. Again, they have the same base, so that cancels 1/2. Very easy. All right, number 3, log base 5 of 1 over 25. So I see this base 5 and I see this 1 over 25, and then I'm thinking I got to change that 1 over 25 to a base of 5. But I'm not sure how to do that. Well, I know 25 and 5 has something in common, so maybe what I can do is change that 25 first. I know that 25 is 5 squared, so that's just 5 squared. But that is not 5 to some power. That is 1 over 5 to a power. So that's not something I can cancel yet. How do I change that 1 over 5 squared so that it's 5 to a power? Well, let's remember from way in the beginning in a year, if I want to move this exponent to the numerator, I will have to put a negative exponent in order to change it. So remember, if you have an x to a negative 1, that's the same thing as move it down because it's in the wrong place, so it's 1 over x. And so same thing, if I have 1 over x and I want to go move it up, I would have to change that exponent to a negative. All right, so now that is negative 2. So that's the answer. All right, let's have you try 4, 5, 6 on your own and then come back and check the answer. Okay, so number 4, like the log rule says, any log of 1 is always 0. This log and the 7 has the same base, so this is 1 because that's 7 to a 1. This exponential and log has the same power, so I'm sorry, same base, so this is just 11. Now we have 3 kinds of logs. The first kind is log base 10. So log base 10 of something. There's always something inside. Log is never on its own. While log base 10 is so common, we will always write this as just log. So if this log has nothing written here, that is known that it is base 10, even though it's not written. And so because it's so common, we call this common log. Okay, so that's the first one. This is very, very common. You see this all the time. The next one is log base e. So log base e, and then we have something inside. Again, log is never on its own without something inside. Okay, so this is also a very common thing to see, and it has another word for it. It's called a natural log. In a natural log, we write it with L and then N, and then that's something. So instead of log base E, we just write Ln. And remember, it is L and not, so L, I write it like that so I don't get confused. Or you can write Ln like this. It is not IN, not in and out. It is just Ln. So please be careful of that. This is called a natural log. Oops. All right, log with other bases, you just write log and then whatever that number is, and then something inside. All right, let's go ahead and apply our rules for these. But first, let's have you pause the video and then determine 1, 2, 3. What are the bases for these logs? Number 1, 10, because there is nothing written that is understood to be a 10. Number 2, Ln means E. Number 3, it's written here, 4. All right, so let's go ahead and practice these without a calculator. So let's try 1, 2, 3, 4, and then we'll do 5 and 6 together. All right, hopefully you gave a good shot on this, and then I'm going to show you how to solve this really quickly. Log with nothing, that's a base 10. So we got to change that 100 to a base 10. So log base 10, so that's 10 squared. 100 is 10 squared. That cancels out, so it's just 2. Natural log has the same base as e, so that cancels. This is 5. Any log of 1 is 0. This one, what we want to do is we want to change this to the fraction exponent form. This cancels 1/5. All right, let's look at 5 and 6. So 5 and 6, what you want to do is either you remember this from Algebra 2, or if not, I'll show you how to solve this really quickly. The whole goal is to solve for x. And to get x by itself, I got to get rid of this part. And to get rid of this part, remember the only thing that can get rid of a log is the exponential version. So the exponential version of this that would cancel it entirely is the same base, but an exponential. So that means I need an exponent that is 2. So then what I'm going to do here, or the way I did it, was I put 2 as the base, and then this all became an exponent. Now, I can't do something to the left without doing it to the right, so I'm going to raise the other side by 2. So now that cancels because the base and the log base are the same, so that's just an x, which is equal to 2 to the 5th. And then we're going to spend some time memorizing the numbers, the 2 especially. So 2 to the 5th is 32. All right, number 6 is the same. This one has no base, so that means it's a base 10. So to get rid of the base 10, I gotta raise both sides by 10. That cancels. X is equal to 10 to the third. 10 to the third is just 1,000. Again, we're gonna spend some time memorizing these numbers. All right, the last thing we're gonna do is just practice using that calculator, making sure we know how to find log buttons and natural log buttons on the calculator. So log 34.5 is about 1.538, and then natural log 23.5 is about 3.157.